He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
Kia ora, and welcome to Elemental from RNZ, our year-long birthday party for the periodic table, which is 150 years old this year. I'm Allan Blackman from the Auckland University of Technology.
And I'm Alison Ballance. And instead of candles on a cake, we've got episodes in a podcast. And today's episode, 76, is a bright, shiny one because we are up to silver. To match our subject, I'm definitely sporting some silver jewellery. There's a couple of rings and, well, where can I find it? A necklace. It's my favourite noble metal, possibly because it's more affordable than gold or platinum or those other pricey things.
Yes, bling on a budget. I actually have to admit to having a silver ring and a what is called a mangle, I believe.
Oh, goodness gracious me, a mangle, I like it.
Apparently. So anyway, silver jewellery quite readily available because silver is quite readily available, I guess. The world production of silver in 2017 was a very precise 38,223 tonnes. And the current price is just a smidge over 700 New Zealand dollars per kilogram, so not ridiculously expensive like some of the other ones that we have talked about on Elemental. It gets its name from the Anglo-Saxon word siolfur, S-I-O-L-F-U-R. And surprise, surprise, that was the Anglo-Saxon word for silver. Vital statistics atomic number is 47, and that puts it in group 11 of the periodic table, in amongst the transition metals, sort of towards the middle-ish of the table, and the chemical symbol is Ag.
And as usual, I am compelled to ask, why the letters Ag? I know that Si is silicon, but Ag?
Ag comes from argentum, which is the Latin for silver. This is kind of interesting because normally we find elements named after places. Here we have places named after an element, which is the reverse of how things are usually done. So silver is in fact an element that's given its name to both a country, Alison?
Argentina.
Very good. And a river, which is very close to Argentina, the River Plate, or in Spanish, the Rio de la Plata, which is River of Silver in that particular language. And if you have a look on Google Maps, you'll find heaps of towns and cities around the globe that have either plata or silver in their names. So, silver's been known since around about 3000 BCE, but it was not as widely used as its precious metal buddy gold in ancient times because it's not always found in nature as the pure element, which is unlike gold in that respect. So silver's always sort of played second fiddle to gold, and part of the reason is probably because silver tarnishes in air, whereas gold doesn't.
I have to say that is the downside of my wearing silver jewellery. It does turn black on me all the time, and that's without going to Rotorua, where a swim in a thermal pool has terrible effects on my silver rings.
Oh, yes, indeed. And so the reason for that is that you've got sulfur-containing molecules down in Rotorua, and they are implicated in the tarnishing of silver because of a little thing called electrochemistry. Little first-year chemistry lesson here.
Oh, goody.
Very, very quickly. So we have silver metal, and what happens is that gets oxidized to the silver plus ion. And so oxidation involves the loss of an electron on each silver atom. It loses one electron and forms the Ag plus ion. And all those electrons end up with sulfur, which forms sulfide, and the tarnish that you see, the black stuff, is actually a precipitate of a thing called silver sulfide. There we go, first year chemistry.
Thank you. Can I ask you for a chemical explanation? There's a home remedy for getting rid of tarnish on jewellery and things like silver cutlery, which involves a sheet of aluminium foil and baking soda or salt in hot water into which you dip said precious silver objects, and voila, the tarnish disappears.
Well, that's kind of the reverse of the process that I've just talked about. So in this case, we've got silver sulfide, and we've got silver plus ions and sulfide 2 minus ions. So what is happening here is that we've got some aluminium in the mix now. And what happens when you place your tarnished silver in contact with the aluminium in the presence of some ions to carry charge and stuff? You get a transfer of electrons from the aluminium, which in fact each aluminium gives up 3 electrons to form Al3+, and it gives those electrons up to silver. And so with those 3 electrons, 3 silver plus ions can each gain 1 electron and form silver metal again. And as you say, voila, the tarnish disappears. You get your silver plus turning into silver, your silver sulfide turns basically back into silver metal. Very, very cool. And it actually does work. It's not one of those things on the internet that is fake. This one actually works. So if you do have some tarnished silver, give that a shot. It works very nicely.
Thank you very much for that explanation.
Anytime. So interestingly, despite the fact that silver does tend to tarnish, it's been widely used in coins. And in fact, the French word for money is argent. So certainly coins, definitely cutlery, and definitely jewellery. And so in all of these applications, what you generally find is you're not talking about pure silver, you're talking about silver alloyed with around about 7.5% copper, and that gives a thing called sterling silver, or 925 silver, or indeed 92.5% silver. So the addition of the copper makes the silver a little bit more resistant to wear, and it sort of hardens it up as well.
Ah, brilliant. Hey, now I have a memory from a distant episode of Elemental, episode 38, iodine, of silver being involved with iodine in photography.
Oh, yes, indeedy. And in fact, one of the largest uses of silver used to be, with the emphasis on used to be there, in photography. And yes, we did discuss this briefly in the iodine episode, so let's talk in a little bit more detail about what goes on there, or what went on back in the days when we all used film. So silver salts, such as silver chloride, silver bromide, things like that, have the property of being light sensitive. And this property was for many years the basis of photography. So what you had was a silver impregnated film. You would briefly expose that to light, and then that would darken the film owing to the formation of elemental silver. And the amount of darkening in the film that you got was dependent on the intensity of the light. And once you'd done that, once you'd taken your picture, that gave you a negative image. And then that could be developed into a positive image, which was the photo that you got. And so that's what happened when you took your roll of exposed film to the chemist's shop.
And those of you under 30 who grew up with digital photography probably have no idea what we're talking about.
Indeed, yes.
Hey, silver and darkening and lightening are involved in transition glass lenses, aren't they? Those ones that miraculously turn dark when you step outside into the sun.
Yes, indeed. And it's the very same sort of process. So silver is used in photochromic or transition lenses, at least those ones usually made of glass. If you've got plastic ones, then they use a different system. So within the glass, you've got microcrystalline silver halides, and they get embedded in the glass substrate. And what happens with them is that in the presence of UVA light, so those are wavelengths around about 320 to 400 nanometers, so electrons from the glass combine with the colourless silver cations, the silver 1+ ions, and they reduce those to elemental silver. And because elemental silver is visible, the lenses appear darker. Then you take your glasses, put them back in the shade, and this whole reaction is reversed. The silver gets reoxidized back from silver metal, essentially, to silver ions, and the lenses become clear again.
I'll try and remember that next time I step outside and my glasses go dark. Hey, what's your favourite use of silver?
Oh, that's an easy one. Of all the metals, silver has both the highest thermal conductivity and the highest electrical conductivity. And that is why I have got silver speaker cables. And yes, everybody, they do sound better.
Oh, yeah.
And silver also is the best reflector of visible light. And so that is the reason why it is very, very often used in mirrors.
Well, I have to say silver mirrors may not make us look any better than we do in real life, but silver does have some really great medical benefits, doesn't it?
Yeah, it does. Silver appears to have some quite remarkable medical properties. So the silver plus ion, the Ag plus ion, is in fact toxic to a variety of bacteria and viruses. And silver nanoparticles are now being incorporated in wound dressings as an antimicrobial agent, and they seem to be very, very effective. Now, the US politician Stan Jones, he's a Libertarian Party candidate in a variety of elections. He's a great believer in the health benefits of a thing called colloidal silver. That's very, very, very small particles of solid silver. So much so that his skin is now, in fact, blue. This is a byproduct of the light sensitivity we referred to earlier. And this condition is called argyria, and I urge you to look this guy up on the web and see the photos.
And that may be one of my most interesting elemental facts ever. Thank you, Alan. I'm going to go online and find a picture of him just as soon as we finish this podcast. And I may even link to something from our webpage, rnz.co.nz/chemistry.
Hopefully you're already subscribed to us as a podcast at your favourite podcast provider. We are RNZ Elemental, and we're back next time with another familiar element, sodium. But until then, it's bye from me, Allan Blackman.
And me, Alison Balance. Mate wā.